Hi, this is E next line, and this my my deadlock avoidance code. So real quick, just walking through, we have necessarily libraries, which include all our studios for input, output, and our units for fork and sleep. And then right here we have our critical constants, so the shared resource, which is of course like the shared process that or the shared file that both of our processes are going to be trying to access. And we have our activity log, which is of course where our activity gets checked, and then our timeout seconds, which is set to 3 because obviously they have 3 seconds. We have global variables right here, just log fp for the log file pointer, and then the timeout occurred, um, which is set, which is flag set by the signal handler when the alarm fires. Um, Scrolling down, we have our timeout handler and our function prototypes right here. This is our timeout handler. Um, it's basically just it's super important. It's basically when the process takes too long and the alarm goes off, the function gets called and then it sets a timeout. And basically just it just kills the processor. So that the other one doesn't exceed the wait time. And so this is what stops the starvation of the process. And then we have our log activity function right here, which is just basically all our logging, and then it gets our current timestamp, formats message, and then prints it out using printf right here, and then it writes it all to the log file, and then this is basically how we track all basically how we just track everything. And then the try acquire resource right here is the most important part of a project. So basically, what it does is it logs the process that is attempting to get the resource, and then it opens a shared one. And then the critical part right here is basically when it sets the alarm for 3 seconds. Remember what we said at top, and then it registers the timeout handler as a signal handler for a sig alarm. And then so then it calls flock with lock x for an exclusive lock. This is a blocking call. So basically, like the process will basically just wait until it gets the lock or the alarm goes off. If the alarm goes off first, the signal will interrupt the flock, and we check timeout occurred. It's true, and then that means that the process started, and we return -1. If the lock um, doesn't, if it's successfully acquired before the timeout, the alarm gets canceled. Return the file descriptor, and then the process has access to the shared resource. So this is pretty much the whole, like the gist of it right here. Again, um, we get the lock, boom, no alarm, but if not, the alarm will go off and we return that the process is starved. Keep going here. Let's see. So here we have the release resource. So release resource function locks the file using the flock lock on, and then closes the file descriptor. So it just basically makes the resource available. And then process task just simulates the work, and then it attempts to get the resource, and then if it works, it writes some data to the file, sleeps for 2 seconds, and then that's like the sleeping is to simulate like work being done, and then it releases the resource. And then let's see, okay, and then our main function, we just open our log, and then create the shared resource, logging the system startup, and then we log timeout threshold, and then the shared resources file all in here. So boom, we can see open the log and then create the shared resource so that both the processes can compete for it. And then obviously use the print statements to see the timeouts. And then making the our child processes. Process one. Um, so the first fork will create the process one, and then in the child process, where PID one equals 0, we log the process ID and then loop 3 times. So pretty simple stuff. And then at the bottom, we kind of just clean it all up, and then we wait. So we just wait for both children to complete, and then it collects their exit status. So when it prints 0, it means it was good, and then if there's 1, that means we got some starvation. We have some stuff to fix here. And then that's pretty much it. Thank you.